Now we're going to actually do what this question asks for. It asks for something called a box plot, and it's honestly the full name of this thing is funny. It's a box and whisker plot. This is the official title of this. I did not make this up. You doing all right? What's that?
I think I remember that from algebra.
Really?
Yeah, me too.
Sweet. I like your algebra teacher. What's another name for P25? If I waited 25% of the way through a football game, how much of the game has gone by? A quarter. So obviously another name for this then, incredibly enough, would be Q1. This is also known as Q1. So Q2 is also known as P50, which is also known as the median. So far so good? Incredibly enough, we have a Q3. We don't have a Q0, Q4. That would be the low and the high. So something called the 5-number summary is the low, Q1, Q2, Q3, and the high. Let me see if you guys can go with me on this. Using this data, the low one is the 664. The high one is the not 6,000. 836. Q1 we did already, right? 706. Q1 was the average of the third and the fourth. So you went 1, 2, you can do it, Jeff. 1, 2, 3, and then took the average. Yeah. Anybody know something interesting to do for Q3? Careful. Start from the bottom. 1, 2, 3, average these.
Q2.
You with me?
For Q3.
For Q3. Q3, yeah. Stay with me now. Q2 is the median. We can do that like we always do. To see the work, real quick, if I wanted to do Q3, that's P75. 75% of 12 is 9. So it'll be the 9th and 10th. 1, 2, 3, 4, 5, 6, 7, 8, 9th and 10th, right? Which is 1, 2, 3, those two, right? So you can always, if you think about it, I'm hoping this makes sense. If I go a certain way in for Q1 from the top, I go the same amount in from the bottom for Q3. That will take down a little bit of your work. That'd be nice, right? So if I average these two, what do I get? 810. So Q3 is 810. And what's the median? There are 12 data points. All right, so halfway through 1, 2, 3, 4, 5, 6. So I'm going to average those two. 766. All right, how are we doing so far? Is everybody semi with me? Or just want to lie to me right now? Okay. It's understood. It's actually not understood, but oh well. So that's the 5-number summary. If I ask for the 5-number summary, that's all I want. Low, Q1, Q2, Q3, high. Here's the box plot. You'll like this. Draw a scale that has those on it. Don't make the scale according to those numbers ever. Make a consistent scale. So I can start at maybe 660. I need to make it up to 840, right? So maybe go by 40s. 660, 700, 740, 780.
Why does it have to be all the way up to 840?
So I can get the high one on there too. You want to have a home for all your data points. Did I count right? Yes, you did, Jeff. Good job. So now, here's the cool thing. You guys with me? So we've done stuff like that before, not a big deal. Put a line over each one of the 5-number summary points. So like 664, put a line there. Trust me. 706, put a line there. 766, put a line there. 810 will be about right there. 836 will be about right there. How we doing? Here's the box part. Box off the middle 3 like that. Pop. And then here's the whiskers part. All right. Is that difficult? It is? Okay. Damn. Like your intense look on your face.
Yes, it is.
believe it or not, this is used a lot. You see this a lot, especially for any future educators, any future teachers. They always want us to have this in the curriculum to make sure that you see this. Yeah?
Which points did you use to draw the lines, please?
The 5-number summary. Yeah. And I just picked a scale that had those in it, right? The scale's got to be consistent. Notice how this is pretty symmetric. Do you see that? Yeah.
Does that kind of like mirror the a normal distribution?
You could possibly see if something is a normal distribution candidate for something like this.
Mm-hmm.
If I had a box plot and it looked like this, I'd say that's not normal. Right? I'd say there's a big time outlier here. You with me? Because most of the data is in here. In fact, can anybody tell me exactly what percentage of the data is in that box? No. I don't know a damn thing about this if it's normal, do I? I don't know if this is normal or not. I like the fact that you guys are keyed in on that, but I do not know if this is normal. So don't go to Chevy and say, at least 0, Jeff. We know exactly. Well, what is this again? This is Q what? 3. And this is Q1. How much is below this? If I'm the 3rd quartile and the what percentile? 75% is below that. How much is below this? 25%. So how much is in the middle? 50. Okay, always 50% in that box. And any of you interested in going, you ever seen like the Princeton Review of Colleges or whatever? If any of you ever looked at any books like that, thinking about what college to transfer to, they always tell you the middle 50% of SAT grades. If you don't believe me, go get the book and look it up. It's a big chunk. They say, here's the middle 50% of SAT from this to this. Because that's kind of like their core, this is kind of their definition of what students they have there. You with me? So that's how they use this there, for example. Okay, that is not terribly difficult. You need to practice it to get it down, but it's not difficult. And the funny thing is, the reason I pulled this up is put this data into your calculator. I got a couple up here if you want to borrow one for a minute. So clear out list 1 and put this data in. Oh, cool. 818, 834. Do one variable stats when you get them all in there. So you get them all in there. Go to stat, calc, 1var stats. Hit enter because it defaults to list 1. You see all the stuff we've talked about before. There's the standard deviation, the mean, blah, blah, blah. Some of you guys have done this before. You scroll down and what do you see? You see those? What? All right. So obviously, I have to see work. It's not, how to just have the numbers appear. But hey, help. What the hell? You have a way to check yourself. That's nice. You get this big old list of 5 numbers, and the calculator goes, hey, I got the same one. You're like, thank God. Probably not both wrong, so we're okay. Unless you put a data point in there wrong, then you're screwed in general. So. And a real quick word about that. Obviously, if you put one data point wrong, everything's wrong. So I normally am pretty good about finding out which data point must have went wrong, and then I grade it as if that was what it was. I'll take like a point or 2 off for not putting it in right, but I'm not going to kill you on every single one. That would so suck. Yeah.
Okay, say you put in the list and you ended up with one less. Is there a way to add in a data point into your list without having to go through and rewrite all the ones after it?
Well, yeah, just go down to the empty spot and put it in there.
And then
And you can resort it if you want to, yeah. Okay. So that's section 3.4, and I just want to do a little preview of chapter 4. I just want want to ask you this. I think I've already asked you this on the first day. You know, does anybody ever go play the scratch-off tickets, or you go put get some numbers for the lottery or whatever? Do we have 3- and 4-digit lottery things?
Yeah.
You can tell I don't play. Because, you know, the only way you don't win is if you don't play, but the best way to make money is to just keep it in the first place, really. So, I'm always, yeah. Would you ever play the number, for example, you have a 4-number lottery. Would you ever play the number 1, 2, 3, 4? Of course not. People are like, no, hell no, that's not going to show up. I'm going to play 7, 6, 9, 3. That's nice and freaky. That's probably going to show up. Of course, that has the exact same probability to show up as 1, 2, 3, 4.
They must say rigged it, and they don't want to do 1, 2, 3, 4 because people might pick it.
Yeah, let's all assume it's not rigged, which might be a big assumption. I don't know.
Yeah, I would assume it is rigged. That's the thing. Because the way casinos run their casinos, and it's all, there's no chance that they have it all calculated out. Guaranteed
Well,
they would love
casinos
it.
are
I'm
really
sure
careful
people
about not
say-
being rigged, because there's a lot of people that come in there and take a look. They just know the probabilities, and they play those. And they'll pay out $2 million to this guy over there, because everybody comes, oh, he won $2 million, oh my God.
Well,
And there's
machine.
4 million people that come in and they pay their money. They're always making money. I don't care how much anybody blows. Yeah.
Their machines, though, are.
So they just know the probabilities. If only people did too, good things would be better. But, so that's right there. I think on the first day I said this. Our brains are kind of hardwired against us with probabilities. They're not intuitive. Probabilities are completely counterintuitive sometimes. What's another example? There's that picture on your original homework sheet. I think I talked about that the first day too. The Monty Hall problem. So if you have 3 doors and one of the doors has an awesome prize and the other 2 have goats, basically, and you pick one and then Monty shows you one of them and says, "There's a goat there." All right, so here's the problem. If you have 3 doors, all right, which one would you pick?
One on the left, right one.
Oh, great! You're doing that to me. Here's my okay. Now, so you pick door number 1. Let me do this first. You pick door number 1. So this is the one you picked, and then I say, well, I'll show you behind door number 3. There's a goat. And then he says, do you want to switch? And most people say, equal chance. Why would I? And actually, there's a better chance you will win if you switch. There is a better chance you'll win if you switch. And here's the basic thing people miss. Once you pick a door, let's say you picked a goat. Which door will Monty Hall open? He has to open the one with the goat. He's not going to open the one with the prize and say, you want to switch from that goat to the other goat? Maybe it's a nicer goat. You with me? I know it's freaky. So I'll show you, once we get into this section, I'll show you the math behind this. But to me, the math sometimes still leaves people wanting. People normally don't trust math very much. And I just want you to realize, if you pick a door, and Monty Hall's going to try to get you to switch, maybe, or just to mess your mind up. That's the main thing with that show. Or Wayne Brady now, or whoever the hell it is. If you pick a goat, and what's your chances you pick a goat in the first place?
30.
66.
66, yeah.
66.6666? Yeah, so 2 out of 3 chance you're going to pick a goat, because there's 2 of them have a goat, 3 doors. You with me? So there's a higher chance you will pick a goat. So when you pick a goat, the door that Monty Hall does not pick will have the prize. Are you with me? So right there, I actually never really thought about it that way. I always go to the math right away, to be honest. But what percentage of the time will you pick a goat? 2 out of 3 times. If you pick a goat, the door that he does not pick has the prize. So 2 out of 3 times, it is better to switch. So will you always win the prize if you switch? Of course not. So somebody's going to come back to me and say, you were my statistics teacher and I was on that damn show. Dude, there's still a 3rd chance you're going to lose, so get away from me, man. Obviously, you must have failed that part because you didn't quite get the point. But you guys with me? So, I mean, the whole thing, anybody play, I think I've already asked this, play poker or and you have pot odds and all that. I mean, the whole thing is playing, you think long term, not short. You accept, the really good poker players accept losses Because if they play a certain way and they play the odds, over the long run, they will win more money, right? I don't know if you're really with me. Because what does the probability really mean? Like, if I roll a die, what's the chances I'm going to get a head? Let me try this again. If I roll a die, what's the chance you're going to get a 3? 1 out of 6. Cool. And that's the real. Give me a break. My brain is like wired strange this way. That's the basic idea of probabilities. The number on the bottom is the total things that could happen. There's 6 total things that could happen, and the number on the top is the ways I see what I want. There's one way to get what I want. So 1/6. What does that really mean?
You're gonna fail 5 times.
Out of 6. So does that mean every 6 times I roll it, I'm going to see a 3? No. So what does it mean?
Well, if you don't see any of those numbers any 6 times you roll.
This is true. But the 1/6 has to mean something, or we just throw this whole damn chapter out, and right there about half the students are like, please don't mean anything. Let's throw this. So what it really means, and think about it, what's the chances, let me go back to my original sideways thinking, if you flip a coin, there's a 50-50 chance you'll get a head. There's a 50% chance you'll get a head. If you flip it once, what the hell does that number mean? It doesn't mean shit. You with me? Probabilities only make sense over a large number of things. So that kind of goes along with what I was saying. If you play poker, you have to look at the long term. If I play this game 100 times and I play it this way, the probabilities say I'm going to win 5% of the time. And the freaking pot is 200 something million crazy dollars, so I'm cool with that. Let me win once. That's all I need. I'm set. You kind of with me? So if I roll a die, 1/6, that means if I roll it 6,000 times, how many 3s can I expect to see? Let's do it again. If I roll it 6,000 times, how many 3s would I expect to see? 1,000. Because what percentage of the time do I see a 3? 1 out of 6. Let me put it on the board.
But the same would not be true of if you roll it 6 times. You wouldn't expect it to happen once.
No, I'd still expect. Roll a 6. Roll a die 6,000 times. I expect. That's the key word actually. Expect 1,000 3s, right? If I get 998 3s, am I freaked out? I'm freaked out that I got enough time in my life to roll a freaking die 6,000 times. I'm a little worried about my life. But I'm not freaked out and get 998 3s. That's what the word expect means. And that, again, that's kind of like what we're talking about. If I roll the die 6,000 times and I got 5,000 3s, what am I thinking about that die? It's weight. For whatever reason, I don't know why 3 would be great, but for whatever reason, that die is weighted. That's really good evidence. Why is it good evidence? Because what I saw was far away from what I expected. Cool. Yes, sorry.
To go back to the door analogy, I don't see how you would have a better chance of picking door number 2, because like, wouldn't it still just be 50-50?
No, because again, you're going to pick a goat most of the time. Now, if you don't pick a goat, if you got the prize, then you don't want to switch. But that only happens 1/3 of the time. What happens more often is 2/3 of the time you're going to pick a goat first, aren't you?
Yeah.
And if you pick a goat, which door is he going to open? The other goat. So most of the time, that last door is going to have the prize.
But if you pick the prize.
I know. If you do pick the prize, then these two both have goats, right?
Yeah.
Then he can pick either one to open, and if you switch, you're screwed. So that's the other side of it. So 1/3 of the time, your strategy would result in a loss. 2/3 of the time, your strategy would result in a win.
But wouldn't it be like, so you pick the prize, and then it reveals the goat, and then aren't you essentially reselecting like which door if he lets you pick again?
No, because you're taking out of consideration the fact that number one, there's no definite thing that you're going to get the prize. So you're operating already under something that's already happened. So you change the environment. So I don't care. I pick a door.
Yeah.
Right? He opens up a door. There's a reason he opened that door possibly. There's a reason he chose that door. If I chose a goat, he had to choose that door. So, let me You do it again. He's not going to open the door with a prize and then look at me and say, "Do you want to switch?" Right?
Yeah.
So if I pick a goat, which I'm most likely going to do, because there's a 2 out of 3 chance, the door he doesn't pick is going to have the prize. But the thing that changes everything is there's a reason he picked the door he did. That's why I can't just discard what he did and just look at what I got 2 doors. I can't do it because there's a reason he chose the door he did. Constantly, right? That's why that has to be taken into account. I can't just say, "Oh, he picked that door, now I got 2 doors, I got a 50-50 shot." No, because his taking that door out of play was done for a reason that changes the probabilities.
And so what do you mean? Like, but if you pick the prize or if you pick the goat, you would still reveal a door, right?
No, but if you pick a goat, he's going to pick a specific door, and then you know that this one would have a prize, right?
Doesn't matter which factor.
That's what you're missing.
Okay.
If I pick a goat, and what am I most likely going to do?
Pick a goat.
Pick a goat. So most of the time I'm going to do that. In those situations when I pick a goat, he's going to open the goat door, so the other door is going to have the prize.
Yeah.
So right there, I should always, I should switch always.
Okay.
Because I have a higher chance of that door being the prize. That other door.
Yeah, I see.
Maybe. It's freaky, I understand. And I don't know, anybody watch Mythbusters? Did you catch this show? They actually did this. They actually tested this empirically.
The show called that this was on.
I don't know. The show title? That's sort of like a Star Trek.
No, I mean,
Episode
like,
47,
the
Trouble
game-
with Triples.
No, the game show. The game show.
Was it?
No. What
Oh,
game?
the game. I'm sorry. I thought you meant the episode.
No, not the
Mythbusters.
episode of the show.
It was called Let's Make a Deal.
Oh, okay.
Sorry, man. It was too good for me to pass up. Just saying that. All right. So let's do it. We actually got a couple of things we've already discussed. The basic idea of probability. The probability of an event. And I'm using the same notation, and this is why I did it earlier. Probability is really a percentage. If you think about it. If 40% of you are men, and I pick somebody at random, what's the chances I pick a man? 40%. So see, that's why we really use the same symbol for percentage and probability. They really are related. Now, obviously, percentages could be over 100. Can a probability be over 100%? No, hell no. 110% chance I'm going to do it. What does it mean? It's so going to happen, you don't even have to get up that day. I don't know what that means. Yeah.
Isn't there a chance like to create a 100% probability for something like, oh, let's do a random drawing and like out of like 10 people here, we're going to give out like 3 cakes and someone wins the drawing twice.
Oh. You wouldn't call that a higher than 100% chance. You define your events as being winning no cakes, 1 cake, 2 cake, or 3 cakes. If you add all those probabilities up, it's got to be 100%. Yes, you always are operating within that framework. So the probability of an event is what goes in the bottom always. Like if I wanted to pick a king out of a deck of cards.
The total, the amount.
The total number. So in the bottom in that case would go 52. If you don't know cards very well, anybody not know cards very well? Like there's 52 cards. Not deep, I'm not talking deep. Not one of the suits in a deck of cards.
Yeah.
Diamonds, hearts,
Clubs,
spades. Spades. Okay, a few of you guys know.
Queens.
So if I do a card example, I have a little handout you can give to anybody who don't know cards too well. And I'm not saying you have to know cards. I'm just saying they just are awesome for probability problems. So on the bottom we go the total number of possibilities. So if I pick a card out of a deck of cards, I have 52 possibilities. No jokers in that shit. On the top goes, so in that case, if I wanted to pick a king, probability of a king, it would be out of 52. How many out of 52? I got 4 chances to do that out of 52. So on the top goes the number that match what I'm looking for. Shoot. So that's the basic definition of a probability. And the funny thing is, the definition never changes. The situations change. And you can argue with me, Jeff, that formula doesn't look like, but it's always this. Okay. And why do you think, sometimes I'll get somebody tell me the answer for Raleigh King is this. Where do you think that came from? That is wrong, by the way. Let me make that a big point. But what do you think their thought process was? 4 kings, you ain't going to get one of them. But do you see how that's, I want to dispel that right now. Right? You don't have a 25% chance. What about all the other cards? And why a specific king? Any of the kings would work, right? If they said, I'll give you $100 if you pick a king out, I'm like, I'm playing that king. What the hell, man? So I don't have just one chance. Now this would be nice if I had a 25% chance. I don't. I have 4 chances to match what he's looking for out of 52 total cards. Cool. Okay. And what does this reduce to, by the way?
0.7.
No, not decimal. What does it reduce to? Yeah, 1 out of 13. There's 13 cards in each suit. How many of those are king? 1. So anytime a probability reduces, that means there might be another physical way to look at the problem. Right? Okay. I think that's enough for right now. We'll keep going in chapter 4 next time.
The ghost door problem, does that only happen once on the show?
No.
What's that, sir?
You were talking, you made it sound like that only happened once, the thing with the ghost doors on the show.
It was like at the end of the show.
Oh, it only happened once ever?
No, I mean, it was at the end of the show, every show. If you didn't get an updated homework sheet, you might want to get that.
Next week there's quiz.
Say again?
Next week. We have quiz.
Yeah, next, a week from today. So I'll remind everybody next time. We have a quiz on 3.3 and 3.4.
When?
A week from today.
Next Wednesday.
Next Wednesday, yeah. Yes. Not yet. I actually made it this morning. I still got to send it up, and then I'll email you with the phone number and everything to call. Depends on what appointment they can make. So I'll send you the phone number. You call them and see what's available. Cool.
So test corrections is when we see the question, but does the bonus questions count too?
You got one shot. No, it's not a dumb question at all, man. It's a question I would ask.
Oh, sorry.
Oh, yeah. Thanks. If you want to, yeah. They're due by the day of the next step.
Okay, yeah. Alright, I thought that was like.
Are you gonna give those back? Are you gonna give those back? This one?
The corrections? Yeah, I would.
The other quizzes from
Are you doing corrections or you never got your quiz?
I just didn't get my quiz. That's correct. I didn't get my quiz.
Which one?
What did you say?
Oh, I know. Oh, I keep forgetting. They're at the bottom of the stack in my office.
That's all right.
Because I remember from last time you asked me, I'm like, I keep getting to pull them out and then just take them with me. So
That's all right.
I got it.
Okay.
You'll get it back.
I just wanted to thank you for explaining to me. So
Yeah.
This guy's not. I was like, this guy's wrong. But I got it, and I was like, oh no, yeah.
That sounds like me.
makes
I
sense.
feel like waiting. That's how I was with some of my math teachers. I'm like, you're
Yeah, but I'm glad I know that now. Cool.
It's not an easy thing to get.
Mhm.
Yeah.
No, it's not, dude.
No.
Chapter 3, which I believe the hundreds is definitely for the next test, right?
Yeah, these two will be due by the next test. Yeah. Okay, yeah. It won't kill you. Yeah.
And also for the on your notes on your schedule or your hours, because on Mondays and Wednesdays I have class and then I go to work in the afternoon. There's a possibility that we can see that on Tuesdays and all your hours at the house.
Yeah, let me think. Tuesday is my weird day because I have like 2 big meetings.
Yeah, I saw your hours.
I think I have hours right before my ugly hours, like 7:30 to 8 a.m. because I have an 8 o'clock class. Let me think. And then I'm out of there by 10. And I'm normally in my office getting ready for that first meeting, but I can't guarantee unless you email me and say you'll be there for sure.
I mean, I guess like maybe like what hours I guess would be good for tonight?
Well,
I
10
know
would
you
be
meant-
okay. I mean, that's when I'm done teaching the end of class. If I know you're coming, I won't go somewhere else, you know.
I just want to go over the standard variation.
Oh, yeah, yeah.
Oh, it's been recorded.
So if you wanna come like, next Tuesday, you wanna come this,
Or, I'll email you, see what.
okay. Yeah, yeah, email me and I can tell you for sure, so, and I'll make sure to be there.
Okay, cool, thanks.
For 3.34, you chart the
X minus X bar,
Yeah,
yeah.
I had not put in, say, actual numbers are -1, -2, -3 repeats. I didn't repeat it,
Oh.
but I did.
Gotcha.
Well, I got the right answers if the sum was right. I didn't insert a space.
Oh, I see, so as long as you actually
Is that
did,
not-
you didn't show it in your table, but
No, but
you
I-
did, it's involved in your work?
It's in the L1 table, so
Okay.
grade, I just didn't.
That's fine. I was worried that you didn't even do it.
No, I just didn't find it.
I'm with you, that's fine.
Okay, actually, I missed last class. I left you a voicemail. I was wondering if you got that when you got on with Nada.
Yes.
Yeah.
Okay.
And I didn't have my homework ready on the day because I know it's late now. I just
Yeah, you can still turn that in.
because I did up to 3-4 actually, so I'm all caught up. I fall behind a little bit. What assignments were? What chapter was it due up
To 3-2,
to 3-2?
and then 3-3, 3-4 is turn in for this next test.
Cool.
Yeah.
And I'm turning the homework in the computer.
Oh, yeah, yeah, you're good, don't worry. Don't worry, I'll keep an eye on that.
And these test corrections are due the day of the next test, right?
Exactly.
Okay.
Yeah.
And there's a potential to make a 20% of these points back?
You missed, you can make 7 points back, you can back up from these.
Okay.
If you do all the corrections, you get them all right.
Perfect.
Cool.
Awesome.
You got one of these, right?
Yeah, I did. I don't have these scheduled together though right now.
Oh, yeah.
Thank you.
Thank you.
No problem. Oh, man.
Thanks a lot, Professor Water. You have a good one.
You too.